Okay, here in this video, we're going to solve trigonometric equations. What this means is that we're trying to figure out what theta makes these equalities true. To add to that, our solution should be only contained between 0 and 2 pi, where 0 is included but 2 pi is not. And the reason for that is because if the circle makes the full circle, you'll be going from 0 to 2 pi, and they're essentially the same thing. So that's why we include 0 and not 2 pi for this case. Overall, the process for both of these are the same. The objective is the same. The only thing that changes is the kind of algebra you use to help you solve for cos theta and sine theta in our case. So for the first one, the best way to get to the solution is to get everything away from cosine so that you can have just cosine theta left. And so if we just think algebra, we should be left with 4 cosine squared theta is equal to 3. And that leads to cosine squared theta is equal to 3 divided by 4. Now, here you might be like, okay, well, I have cosine squared theta by itself, but that is not what we want. We want just cosine. So the only way to do this is to square root both sides, and on the right, you should add a plus or minus radical 3 over 4. I'm going to go ahead and rewrite this so that it makes a little bit more sense for us. So that is cosine theta is equal to plus or minus radical 3 divided by radical 4. Here, I hope that it becomes a little bit more evident that radical 4 can be simplified. So we end up with radical 3 over 2. And this isn't a surprise. This should kind of lead, in most cases, to a special right triangle. This makes it easy for us to worry about the trigonometry at the very end. What this happens to be is that we're ending up with two different kinds of questions here. Is when is theta for cosine going to give us radical 3 over 2? And then when is cosine theta, specifically the theta, going to give us negative rad 3 over 2? And to keep things simple, anytime you have a negative, it's really for a sign, right? It's really for a quadrant. So in this case, let's do the left. So the question is, what theta is going to give us radical 3 over 2? And if you may already know, radical 3 over 2, where we have for cosine, radical 3 is going to be, let me redraw this triangle because it looks a little wonky. So this should be radical 3, this should be 1, and this should be 2. So if you haven't already found out, this is pi over 6, right? So where is our reference triangle going to be? Since for our first part, cosine is positive in quadrant 1 and quadrant 4, right? So if we do the math, this is radical 3, this is 1, this is 2, and the same thing goes for the bottom, except our y. Our y changes, and it's 1 and negative 1, but we don't care because cosine is still positive here. So the question is, what angle gives us this first triangle here, right? What angle right there? And if you already paid attention, our first theta should be pi over 6, right? Pi over 6 is 30 degrees. Now the question that follows is, what theta gets us down here? And we're not going to get to all the small details of like, hey, what is that? But that should be 330. And if you don't know, that's 11 pi over 6. Please watch a video on the unit circle in order to get better at locating these reference triangles. On the other hand, we have cosine theta is equal to negative radical 3 over 2. And this yields a different little quadrant, right? So cosine is negative on the second and third quadrant. And this becomes negative 3 here for the radical. That becomes 1, that becomes 2. And the same thing goes down here. So again, we already know that the triangle in reference is pi over 6. The question is, how many pi over 6s are there to get us to that triangle and that angle? And how many pi over 6s are there to get us down here? So if you don't already know, please again, watch a unit circle video. That one should be 5 pi over 6. Okay, and the next one should be 7 pi over 6. Okay, so the 5 pi over 6, 7 pi over 6 is what the theta has to be so that this is equal to this on the right hand side. On the left hand side here, cosine theta, theta has to be either one of these to yield a radical 3 over 2. And that's the whole purpose of this, right? So you can go ahead and join these two together as one whole answer, or leave them like this. This is a great way to show your work, and then you're done, right? So with that being said, we're going to go ahead and move on to this next one. This one, if you may have had some experience with this, it really should remind you of a quadratic equation, right? And in order for us to really see that, we're going to go ahead and, when we see this type of equation, the best thing to do is let sine theta equal x, right? And then just rewrite. If that is true, then we have 2, not sine squared theta, but rather x squared, okay? Minus x minus 3, and that equals 0. Now that puts us in a better position. We are then capable of doing the diamond method to solve for x. So for those of you who recall, the diamond method is going to be a, b, c, right? So a times b goes on top, and that's going to give us -6, and then b goes on bottom. That gives us -1. 1 second. And all you have to do now is go back to the basics of what gives us -6. So what two numbers gives us -6, and what adds up to -1. So this should be -3 and 2, if I'm not mistaken. That should be it. So then that's a plus. And to finish this off, what goes in the front is going to be this leading coefficient and x. So here we have 2x here and 2x here. So before we actually write it in the fully factored form here, right, we actually have to make sure this is fully simplified. So 2x minus 3, I cannot factor anything else, so that is 2x minus 3. However, on the right, we can factor out a 2, so that actually leaves us with, let me rewrite that so it looks a little bit better. That's 2 times x plus 1, and that goes here. That's what we want, right? This is the juice right there. And then we're done in terms of factoring. This is where we're now able to kind of go back to where we were before and actually start solving for sine theta. So instead of having x now, we're actually reverse the process here and then plug in sine theta back. So that's 2 sine theta minus 3 or equals 0. Let's set this up for the next step. And then sine theta plus 1 equals 0. Now, for the left-hand side, again, we do as we did before and then sort of solve for sine theta. So I'm going to skip a couple steps here, and that should be sine theta is equal to 3 over 2. And the other one should be sine theta is equal to -1. Now, I want you to really pay close attention here. What theta gives us 3 over 2? Well, this is something that goes sort of unnoticed, but for the most part, for sine theta, our range is -1 to 1. What that means is no matter what our theta is, right? Pi over 2, pi, it don't matter. 3 pi over 2, 11 pi over 6, whatever. We can only get something out that is between -1 and 1. And if you notice, 3 divided by 2 is actually 1.5. So the question is, can we ever get that? Is that in our range? And that is a no. It's out of our range. So in other words, you would just say for that part, it's undefined. And you don't necessarily have to put undefined if we're having this part over here. But if it was by itself, you would put either out of range or undefined. So now, in fact, we did all this work, but we can actually only solve for sine theta. So the question is, what theta does this have to be so that when you apply it to sine theta, or sine rather, it's going to give you an output of -1. And if you remember, -1 really only exists down here. So the question is, what angle puts us at 270? And that answer should be 3 pi over 2, right? And 3 pi over 2 is the only theta that if you plugged in, it would give us -1, right? And then we're done. There's nothing else to this, but one thing I do want to again shine a little light on is on this part here. Be careful when the 3 over 2 doesn't necessarily make sense. It's probably because of this part here.